Okay, so first let's get some intuition behind the idea. So if we take these two random points in the xy plane, we can sort of imagine um, that we're trying to get from the blue point to the red point. So how are we going to do that? Well, you have two options. You can either walk this way, down, and then across, or you can walk along a line in order to get there. And we can see that um, it doesn't really matter that we're looking at a um, like this specific diagram, because we could just say, um, why don't we consider the line uh, or the point x2 instead now over here. Or we can say, okay, it's over here, it's over here. And either way, you'll always get this triangle. So, just moving this back. So the first question is how steep is the line? Because we could say, okay, well, we can walk this way, but that doesn't get us down to our x2, y2, doesn't get us down to our red point. So we know that we want to walk at some sort of angle, um, or along some sort of line. And the way that we're going to do this is we are first going to look at the components. So first we're going to walk down, and then we're going to walk across. And we're looking at the ratio, the change in y compared to the change in x. And that'll give us the ratio of, in a sense, that'll give us our steepness. So we can just say m is equal to delta y over delta x, which is equal to, well, we know we're going from the blue point to the red point, so we're looking at our y2, y2 minus y1 over x2 minus x1. And this should look somewhat familiar. Okay, the next question is how do we guarantee that we're hitting both points? And the reason why I bring this up is because you can have sort of, oh wow, that is not a great line. Let me redraw it. You can have this one line that goes through the 2 points. We can also see that if we shift this line, the slope stays the same. We still have that same sort of triangle. That's not a great triangle, but you get the idea. We always have that triangle, independently of where we move this line. So we want to ensure that we're hitting both points. Well, how do we do that? I'm going to cheat a bit. We know that y is equal to mx plus b. So the first thing we're going to do is we're going to say, okay, well, I know that we want to hit this point. And we can see that all the lines are unique. So what we're going to do is we're going to say, okay, I'm going to plug either of my points in, and then from there, I can guarantee that I'm going to hit both, because we have the slope, and then we also fix one of our points. And as soon as we fix it, that's saying, okay, we're going from here, and now we snap to that. So the first thing we're going to do is we're going to plug in our points. So in this case, plug in our points and solve for b. So we'll choose y2, and our x2 plus b. And this fancy symbol just means if this, then this. Which means that our b is equal to y2 minus mx2. And I'm sure you've seen like a lot of different forms of these equations. I think this is somewhat close to, I forget what the form is called. It's either standard form or something like that. But you can also derive the equation. It's not that hard. But, okay. So, after all this intuition, well, now let's apply it. So, our question was, you have the point 3, 4, and you want two lines, and then g is equal to nx plus, we'll say c. Two linear equations, two lines that pass through that point. Okay, well, the first thing is, let's think about the easiest way to do this. Okay, so we have our point, and I'll just sketch it out over here. We have our point, we'll say 3, 4. We have our point 3, 4. Well, if we pick the origin is 0, 0, then we know that everything is going to be relatively nice. And the reason why is because our x at 0, 0 is 0, and our y at 0, 0 is 0. Okay, now let's do that same sort of idea. How do we walk from the blue point to the red point? Well, all we're going to do, go along here, and then go straight up. And that'll give us this triangle. Okay, now we gotta figure out, okay, well, what are our delta x's and what are our delta y's? So in this case, from here you can clearly see it from the graph, but we'll do it algebraically. For our red point, we'll say this is x2, y2, and then our blue point is x1, y1. So the equation of our line is y is equal to y2 minus y1 over x2 minus x1 times big X plus b. Okay, in this case, our y2 we know is 4, y1 is 0, over x2 is 3, and y1 is 0, x plus b, and this is just equal to 4 over 3x plus b. Now, how do we guarantee that we hit both points? Because we could equivalently say that this line has the same slope as this one, as this one, as this one, all of these. But how do we guarantee it? Well, we fix a point, okay? So the first thing we're going to do is we take our new equation, this, and we start plugging in one of the points. I'm going to choose the easy one, 0, 0. So plugging in 0, 0, we get 0 equals 4 over 3 times 0 plus b, and all this means is b equals 0. And that's it. Which means that we're left with the equation y equals 4 over 3x plus 0. So that's the first one. Okay, the second one, the second equation, we can do a similar sort of idea. in this case, we're going to make it even simpler. And the reason why I'm doing all these easy ones is, one, it makes my life easy, but two, it's also a lot clearer to see. So instead of choosing the origin, now we're going to choose the point 0, 4. So 0, 4. Okay. So what's our first step? Well, we got to find the slope of the line. The slope of the line, well, we're just going straight across. That's not a great line, but let's say it was perfectly there. I'm just going to move it. So it goes straight across. Okay, well, let's see it algebraically. So we know that G is equal to delta y over delta x times x plus c. Okay, well, that means that G is equal to delta y is y2 minus y1 over x2 minus x1, x plus c. Just make that clear. And then G is equal to, well, what's our y2? y2 is 4. 4 minus 0 over, 4 minus 4 over 3 minus 0, because this is 0, 4, 3, 4, times x plus c, which means that G is equal to 0 over 3 x plus c, and finally we get G equals just c. Okay, now what are we going to do next? The next step is, okay, how do we hit both points? Well, in this case, even if we left it as this, we'd be able to see it clearer. So first I'll use this equation actually. So we know that our G, or our Y in this case, quote unquote, if we pick this point, our Y is 4, and that's equal to 0 over 3 times x. What is x? X is 0, and then this is plus c. Okay, well, 0 times anything is 0, which means that we're left with c equals 4, which means that our final equation is G is equal to 0 times x, 0 over 3, doesn't matter, 0 over 3x plus 4. And then a nice way to check it is we can just plug in the values at the point x, and we should see that both of them hit 4. So we'll just double check it. So we have 4 over 3 times 3 it plus 0 is equal to, in this case, we just have 4 over 3 times 3, 4, and this is equal to just 4. Where do we get this 4 from? Well, we plug in our x, we get 4. We plug in our x into here, we get 4 over 3 times 3. I'll make this clear. We have here y. Did I use f? No. Y, and then here we have g. So I hope that clarifies it. But yeah, so it's a good idea to get some intuition on what we're doing, and then from there we start asking questions.